Okay, today we're going to do the colored ice and density demo. We're going to look at the density of cold water and warm water and determine if they are the same or if one is more dense than the other. So our problem today is the density of cold water more than, less than, or equal to the density of warm water. So our variables that we need to have in our hypothesis, creating an if, then, because statement. Remember, if is the variable you're testing, the independent variable. So we are testing our water temperature. So you need to decide if you're going to say if cold water, and then choose one of those things, more than, less than, or equal density to water. So if I was to write this, I would say, if I test the density of cold water, then I will find it to be more dense than warm water because, and give me a reason. Okay, so think about what you know about density, the amount of matter in a given space, and what does all of this mean? Is it the same? Is warm water more dense or is cold water more dense? So make sure you write out your hypothesis. What we're going to do now is you should see a bunch of drawings on your sheet. The first two are with an ice cube, one's in cold water, one's in warm water, and you need to be able to describe what's going on with them. Since I have no way of really giving you a way to draw things, what I'm going to do is in this beaker right here, this is cold water, and this one is warm water. I can tell from the outside temperature, but if I also want to check, I notice that this one, on my thermometer, it's still going down. It hasn't settled, but it's already less than 15 degrees Celsius. This one was chilling in my fridge for a while, about 6 hours. So it's roughly 10 degrees Celsius. This one now, it's going to shoot up and show, yeah, this one is much warmer because I microwaved the water for a few minutes to warm it up. Okay, this one is still going, still going. This one is about 43 degrees Celsius. So there's a bit of a difference there. Okay, so what I'm going to do is I'm going to place an ice cube in each of them. And all I did was put food coloring. I happen to use some sort of purple in each of them. They're already starting to melt in my small beaker here. I'm using my tongs. But what I want you to notice when we do both of them, you notice how quickly on this one, the ice cube is melting. Let's see if I can get this so you can see it better. And it's all going to the bottom of the beaker. The ice cube is more colder, much more colder, really bad English, is colder than the warm water, so it's falling down. And if you remember back to 8th grade with those convection currents, you can see where the cold water is pushing the warm water out of the way so it can settle at the bottom of the beaker. You notice here where the water is colder, the ice cube is still colder, so it's going to go down, and you notice all that really cold water is settling at the bottom of the beaker. Okay, that's what I want you to get from these two. That's all I'm trying to show you here. I apologize for any glare on this. I don't know how else to do this so that you can see what I want you to see. All right, so this one is totally done. Okay, you can even see where the ice cube is still pushing down. And then this one, you notice the cold water is settling at the bottom. All right, so make your drawings, explain what's going on, use those terms like convection current, and it's the cold water is pushing it down. The reason being the cold water is more dense. There's more molecules of water in the same space, so it's pushing that warm water out of the way. So warm water is less dense. It takes up more space because the water molecules spread out. Okay, see if that helps you. Now, on your next picture, you have two beakers, and you're going to have to make like a little circle in the center of them or describe what's going on. What's going to happen is I have two jars here with one's got cold water and one's got warm water, okay? And what we're going to do is we're going to put them to the bottom of the beaker, and in these beakers, these are both cold water. Okay, and what we want to see is what happens with the water from the beaker. Does it mix with the water from the baby food jar? Does it mix with the water in the beaker, or does it stay where it is? Now I will tell you, some water for sure will come out of the baby food jars, because as I'm pushing these down, it's going to displace the water, so some of this will come out. So the first one I'm going to do is hot water in my baby food jar. I'm going to use my tongs to hold it and put it at the bottom of this beaker. Okay. Now you notice all the water is coming out of the baby food jar and it's making a layer. The warm water is laying on top of the cold water. It is not going down to the bottom. All right. I'm going to do the other one. And here I have cold water, and it's roughly the same temperature as the water in the beaker. Okay, so you notice what happens. See if I can get this closer so that you can see what's going on. Here's the hot water one. Can you see the layering? Right here, right above the baby food jar is all the warm water. All the cold water is staying down below. It's not leaving and settling at the bottom of the outside beaker water, okay? It's not mixing. So the warm water is taking up space above the cold water, again showing us that cold water is more dense than warm water. Now this one, you notice the water's really not mixing either, okay? Because it's the same temperature water. All right, so get your explanations done. Then you have some questions you need to answer. The first one is talking about why do ice cubes, when you're drinking ice water, why do the ice cubes float to the top? Okay, you need to answer that one. And give me as much information as you can. Don't just give me the easiest answer. Think about it. What causes that change in density? Number two, you go in to buy some ice cream and you took it out of the horizontal freezer and it has no lid. Why? Which one is better for keeping cold air in? The upright ones with a door or the horizontal ones? Okay. The third one you should be able to answer from this little demo. What can you conclude about the densities of warm and cold water? The fourth one, the fourth question. So you're at a 4th of July party. Maybe, maybe not because of pandemic. But if you're at a 4th of July party and you see some pops floating in a cooler and some sitting at the bottom, think about density. Which one is more likely to be floating? Which one's more likely to sink? Think name brand pops. So things like Coca-Cola, Orange Pop, Grape Pop, Dr. Pepper, any of your diet pops. Think about what that means. Which ones will sink and which ones will float? I need 3 brands that will sink, 3 brands that will float, and tell me why each will do what they do. All right, that's all I have for this demo. Have a good day.